Jai Hind everyone. I am Professor Devendra Singh taking this course on machine design, and this is the 7th lecture of this module. In the last lectures we have discussed the various types of loads and some introductory definitions related to machine design. Now, we are slowly moving towards the design process. So, this lecture primarily will consist of the theories of failures and various types of the modes of failure against design, design against the static load. So, the outline of this lecture includes the modes of failure under static load. We will discuss a little bit about the various modes of failure under static load. Then we will discuss about the factor of safety. Every designer uses the factor of safety in his design to make his design safe against odd situations. So, सभी को एक वाइजली एक फैक्टर ऑफ सेफ्टी अपनी डिज़ाइन में इंक्लूड करने की आवश्यकता होती है डिज़ाइनर को, और ये उसके एक्सपीरियंस और विजडम पे डिपेंड करती है. देन we move to the introduction of theories of failure. Then we will discuss about the various theories of failure like maximum principal stress theory, maximum principal strength theory and maximum shear stress theory. In this lecture, if time permits, we will complete all these theories of failure in this lecture. As far as the modes of failure and the static load are concerned, before discussing the modes of failure, we should understand what kind of the failures, कितने तरीके के failure हम अब समझते हैं कि कितने तरीके के failure हमें consider करना चाहिए और सोचना चाहिए. So, types of failures primarily जो failure है किसी भी product का, किसी भी design component का, device का, machine का, वो हम दो तरीके से, और ये दो तरीके के failures मानते हैं. First is the engineering failure and second one is the physical failure. Now, what is engineering failure? So, engineering failure में जो component है, जो machine है, device है, उसमें किसी तरीके की टूट फूट नहीं है, बट वो डिवाइस जो आपने डिज़ाइन करी है, जिस पर्पज़ के लिए डिज़ाइन करी है, उस पर्पज़ को किसी एक इफेक्टिवनेस के साथ, किसी एक एफिशिएंसी के साथ हम रिकमेंड करते हैं. सो इफ दीज फैक्टर्स आर नॉट अचीवेबल, then it is considered as engineering failure. एक सिंपल सा एग्जांपल ले सकते हैं एक बॉयलर का. So, suppose a boiler is designed to produce the steam with an efficiency of 40%. Efficiency of 40%. After few years, due to some reasons, maybe scaling is one of the reason, the heat transfer rate may be affected and the steam production is reduced to 35%. Boiler is still able to produce the steam. Boiler अभी भी steam जनरेट करने में सक्षम है, लेकिन उसकी efficiency due to some reason reduce from 40% to 35%, जबकि हमें चाहिए 40%. So, this is called engineering failure. It is working, but the efficiency has reduced lower than what is required. So, this is called engineering failure. And physical failure is, suppose there is a bursting of the tubes or a machine which gets damaged, shaft broken into pieces. This is physical failure. So, a designer design the components to avoid this. He recommends the conditions, maintenance, etc., to avoid the engineering failure. So, as far as the static load is concerned, so what modes of failure may be possible? So, इन्हीं दो केसेस में इनको हम डिवाइड करेंगे और प्राइमरली तीन तरीके के फेलियर हमारे सामने आते हैं. पहला है इलास्टिक डिफ्लेक्शन. व्हेनेवर यू अप्लाई ए फोर्स ऑन एनी मटेरियल, इट इज सब्जेक्टेड टू डिफ्लेक्शन. इट इज अवर लिमिटेशन. ये हमारी लिमिटेशन है कि हम उस डिफ्लेक्शन को ऑब्जर्व करें या न करें, बिकॉज इन यूनिवर्स देयर इज नथिंग पॉसिबल which is perfectly elastic. So, if whenever a force is applied on the material, it will subject it to a deflection. So, if the deflection is up to the elastic limit, that is considered elastic deflection. But here, if I consider a case of a shaft, if I consider this is a shaft right. This is a shaft and it is rotating about this axis. When it is subjected to some power transmission, it will be subjected to some kind of bending load along with the torsion. So, it may get deflected. It may get deflected like this. So, this point will become here and I have to select the another suppose, and on the lower fiber this point becomes here. This is here and this is here. मैं इनको नाम दे दूं. This is suppose point A. So, after deflection it will get A prime and another when it is not deflected, then another point at the lower fiber is B and after deflection A B prime, ये B prime पे पहुँच गया. अगर ये डिफ्लेक्शन नहीं हुआ, तो यहाँ से ये A prime पे एक्सेस के अबाउट वट एवर इज द diameter, whatever is the radius, that is the amplitude of the vibration of this mass about the axis. और कक्षा 12 में सभी ने पढ़ा है कि एनर्जी एसोसिएटेड विद एनी vibration is directly proportional to amplitude square. But if it deflected from A to A prime, this is even in an elastic deflection, as soon as you remove the force, it will regain its own shape. So, the amplitude will become twice, amplitude becomes 2 times of the radius, because it will reach here A prime, then on the other side. So, you may calculate the amplitude will increase, and if amplitude increase, the energy associated with the vibration of this mass of this particle will increase. Where this energy coming from? ये एनर्जी आई कहाँ से? And if this shaft is a part of a vehicle, एक कार की एक ये shaft है, तो उस कार पे ये एनर्जी आई कहाँ? एनर्जी हमारे कहाँ से आती है? फ्यूल से. फ्यूल इज द सोर्स ऑफ एनर्जी टू रनिंग अ व्हीकल. ये एनर्जी अपने आप ना तो हम पैदा कर सकते हैं ना डिस्ट्रॉय कर सकते हैं. तो फ्यूल एनर्जी विल बी कंज्यूम्ड, विल बी एसोसिएटेड दिस वाइब्रेशन, एंड दिस वाइब्रेशन विल अफेक्ट योर माइलेज, विल अफेक्ट द comfort level. So, this is considered as a failure, because if it happens in any vehicle, then there will be वहाँ पे जो है consumers की कमी होगी, ultimately वो fail करेगा. So, this is considered the failure against a static load, even if it is a constant load, and if it is beyond certain limit, the deflection, that is considered the failure under static load. This is one, and it is engineering failure type. This is the type which is considered as engineering failure. So, this is one thing. Second, अब हम फोर्स लगाते हैं, इलास्टिक डिफ्लेक्शन के आगे चलते हैं, then plastic deformation or general yielding will start. Stress strain diagrams we have discussed in the last lectures. So, general yielding will take place, means plastic deformation will take place. इसका मतलब कि W लोड लगा और A प्राइम B प्राइम इसकी परमानेंट डिफॉर्मेशन हो गई. सो अगले दिन सुबह उठ के आप अपनी कार में जाते हैं, सेल्फ फुट लगाते हैं, बट ये घूमता नहीं है, बिकॉज किसी भी वेट को H से हाइट से ऊपर ले जाना है तो आपको कितनी एनर्जी उसके लिए चाहिए? mgh उसकी पोटेंशियल एनर्जी है, इतना उसे ऊपर लेके आने के लिए इतनी एनर्जी चाहिए इक्विलिब्रियम कंडीशन में. यू नीड टू सम मोर. So, if this is plastic deformation, तो इनिशियली लोड कहाँ था? जो लोअर था वो था इस डिस्टेंस पे. सपोज इसी केस को मैं अगले केस में बात कर रहा हूँ कि इलास्टिक डिफ्लेक्शन से परमानेंट डिफॉर्मेशन हो गया. अगर इसका डायमीटर d है, तो जब आपने ये गाड़ी बंद करी तो d/2 डिस्टेंस पे पॉइंट B रहा. प्लास्टिक डिफॉर्मेशन हो गया, सो दिस डिफरेंस बिकम्स हाई. सो ये मास के लिए मास तो सेम रहा, बट डिस्टेंस बढ़ गई, तो अभी से शाफ्ट को घुमाना पड़ेगा तभी व्हीकल चलेगा. शाफ्ट को घुमाना पड़ेगा तभी व्हीकल चलेगा. तो तो अब इसको ऊपर घुमाने के लिए आपको ज़्यादा पावर की ज़रूरत है। वो अगर आपके व्हीकल के पास होगी तो इट विल स्टार्ट, बट वाइब्रेशन विल बी देयर, सो इट विल अगेन कंसिडर्ड बिकॉज इट विल अफेक्ट द riding quality, it will affect the mileage. And there are, this is a one simple example I am taking here to illustrate the effect or consider this effect as a failure. So, this is, there is no physical fracture in this shaft, but it is not performing with the effect or efficiency what a consumer or designer needs to get. So, this is another case of failure. So, these are the two modes of failure under static load, and the third one, that is evident if shaft get break will get break. अगर shaft दो हिस्सों में टूट गई तब it will not able to perform, it will not able to work. This is evidently, anybody can say this is a failure. So, these are the three modes of failure under static loading, right. Now, to avoid these kind of failures, what a designer do in his design, he use a factor that is in numbers is known as factor of safety, and the value of factor of safety depends on the wisdom and the experience of the designer. If you take the higher factor of safety, it may make your design bulky, it may cost, it is always result in the higher cost if you include the higher factor of safety. If it is lower factor of safety, it may cause some danger. So, optimum value of factor of safety we need to apply. कभी कभी हम इसको ओपन नहीं करते हैं, कभी कभी मोनोग्राम्स में आप देखते होंगे किसी क्रेन पे, सपोज फॉर एग्जांपल ए क्रेन you design for a load of 50 kilonewton, suppose 50 kilonewton. डिमांड आई, एक आदमी ने कहा कि मुझे 50 किलोन्यूटन तक के लोड उठाने, क्रेन डिजाइन कीजिए, क्रेन हुक डिजाइन कीजिए, कंपोनेंट या कंप्लीट सिस्टम. सो व्हाट ए डिजाइनर विल डू, he will be using the factor of safety in two ways. Either he will consider the load 50 किलोन्यूटन के बजाय वो कहता है कि 50 मांगा है, मैं 100 किलोन्यूटन के लिए डिजाइन करूंगा. तो फैक्टर ऑफ सेफ्टी कितनी होगी, इसमें दो दुगना लेके उसने डिजाइन किया. एक दूसरा हो गया स्ट्रेंथ, मटेरियल है, दूसरा है स्ट्रेंथ. स्ट्रेंथ हमने कहा कि एक मटेरियल था जिसकी स्ट्रेंथ 320 मेगापास्कल थी, इसको लेके डिजाइन करूंगा, लेकिन जब मैं डिजाइन करूं तो इस स्ट्रेंथ को मैं 160 मेगापास्कल ले लूं, तो भी मैंने अपने मटेरियल में, अपने डिजाइन में सेफ्टी इंक्लूड कर दी. यहां भी मैंने इसको आधा करके लिया, या तो स्ट्रेंथ आधा कर दिया है, स्ट्रेंथ को 2 से डिवाइड कर दिया है, या इंड्यूस जो अप्लाई लोड है उसे 2 से मल्टीप्लाई. ये 2 क्या है, दिस इज ए नंबर विच इज कॉल्ड फैक्टर ऑफ सेफ्टी. ये मेरी डिजाइनर के विजडम पे, एक्सपीरियंस पे डिपेंड करेगा कि, और मटेरियल जो सेलेक्ट करेगा, डेफिनेटली देयर आर नंबर ऑफ फैक्टर्स, बट अल्टीमेटली डिसीजन विल बी टेकन बाय द डिजाइनर. सो स्ट्रेंथ हमने आधी की है, या इसे 2 से गुणा किया, यहाँ 2 से डिवाइड किया, तो आप स्ट्रेंथ को या तो कम लेके डिजाइन करें या लोड को हाई लेके डिजाइन करें. योर डिजाइन विल बी in safer zone with the desired factor of safety. A factor of safety may be asked by the consumer or may be decided by the designer what should be the optimum factor of safety for a particular design we should use. So, this is a very important factor in our design, as we have discussed selection of material. Selection of material is also affect what factor of safety we should use. There are number of materials where higher factor of safety, there are number of applications where higher factor of safety is mandatory to use. For example, if we need to design a longitudinal butt joint for a boiler cell, we should always use 4.5 or more than 4.5 factor of safety. That is a recommendation for the safety purpose. So, there is some standard norms we will discuss later when we will come to the boiler cells. So, I have discussed what is factor of safety. So, factor of safety is a factor that is a number the designer use in the design to make it safe, the what you are designing make it safe against some unprecedented conditions. Unprecedented conditions आपका लोड बढ़ गया, मटेरियल में कोई मटेरियल यूज़ होते हुए रस्टिंग हो गई, डायमेंशन कम हो गया, या कोई खुराफाती आदमी आके ज़्यादा लोड के साथ किसी मशीन को ऑपरेट करने की कोशिश की, दैट इज़ अनप्रेसिडेंटेड. एक्सीडेंट ऑन रोड, दैट इज़ अनप्रेसिडेंटेड. उसमें भी हम इस्तेमाल करते हैं ये सब फैक्टर ऑफ सेफ्टी. वाई डज ए फैक्टर ऑफ सेफ्टी नीड्स इन डिज़ाइन. एक फैक्टर मैं डिस्कस कर रहा हूँ जब से फैक्टर ऑफ सेफ्टी पर बात करना शुरू किया इस लेक्चर में, कि हमें अनप्रेसिडेंटेड कंडीशंस को अवॉइड करना है. दैट इज़ द नीड. बट व्हेन वी डिज़ाइन समथिंग, there are a number of assumptions we use for the simplicity of the simplicity for make our analysis simple. So, whenever you add an assumption, it invites the danger. So, if assumptions are more, you need to use the higher factor of safety. The data about the material, जो मटेरियल आप ले रहे हैं उस मटेरियल की जो प्रॉपर्टी आपने ली, ये 320 मेगा पास्कल, ये कितनी रिलायबल है, रिलायबिलिटी अबाउट द डाटा. अगर आपने जो डिज़ाइन किया है कंपोनेंट, मशीन, डिवाइस, ऑपरेटर्स, व्हाटएवर यू हैव डिज़ाइन, इफ इट फेल्स, व्हाट विल बी द कॉस्ट ऑफ फेलियर. मॉनेटरी लॉस कितना हो सकता है, लाइफ का लॉस कितना हो सकता है. तो ये सारे फैक्टर डिज़ाइनर will have to consider when a factor of safety is to be included in the design. तो किसी भी डिज़ाइन के लिए मैं ये सजेस्ट करता हूँ कि अगर डिज़ाइनर के पॉइंट ऑफ व्यू सोचें तो देयर आर टू मेन थिंग्स. यहाँ मैं कुछ फैक्टर ऑफ सेफ्टी के साथ कुछ एडिशनल कहना चाहता हूँ कि इफ़ यू डिज़ाइन समथिंग, ऑलवेज रिमेंबर योर डिज़ाइन मस्ट बी सेफ and economical. These are the two things which should be in your design. Otherwise, your design ultimately eventually will fail. चाहे वो यूज़ में फेल हो जाएगा, सेफ नहीं है तो यूज़ में फेल हो जाएगा, और अगर ये इकोनॉमिकल नहीं है तो उसके लिए कंज्यूमर नहीं मिलेगा. दैट विल आल्सो कंसिडर्ड एज अ फेल डिज़ाइन. सॉरी. So why does a factor of safety need in design? So the first is uncertainty loading conditions that we have discussed. हमने 50 किलो न्यूटन के लिए डिज़ाइन किया था, लेकिन आके किसी ने 80 किलो न्यूटन का लोड उठा दिया. सो उसके लिए हमें फैक्टर ऑफ सेफ्टी होनी चाहिए. तो उसके लिए मैंने एग्जांपल लिया कि अगर 50 किलो न्यूटन आपने मांगा है तो मैं मानूंगा कि कभी कभी हबड़ा दबड़ी में या कोई अनएक्सपीरियंस्ड आदमी इससे बढ़ सकता है, तो आई कंसिडर दिस लोड 100 किलो न्यूटन. 2. So it depends, if it fails, what cost will be there for the failure. So उस कंडीशन से मैं देखूंगा कि इसे 2 लेना चाहिए मुझे, कि 1.5 लेना चाहिए, कि 1.25 लेना चाहिए. It will be there. Then the reliability of data used in the design, like material properties that I have discussed. Just number of assumptions made in the design that I have discussed. Every assumption will invite the danger. So you have to incorporate something in your design to fight against this. The effect if failure takes place. So monetary or life loss. So life loss should not be, must not be there. We should ensure. I believe if someone is able to purchase, well and good. If he is not able to purchase, it is always better to not purchase if it is life threatening. So factor of safety in mathematical formula for factor of safety is simple. This is the failure stress upon allowable stress. Allowable stress, what amount, what magnitude of stress you allow to induce in the design components, and what is the failure stress. Or if this is failure stress or nominal में बात करता हूँ तो failure stress is load upon area. So in case of the failure stress, I can write the failure load upon allowable load. So on the basis of the materials, we may have the two different formula for brittle material and the ductile material. So, for ductile material, we have discussed the stress strain diagram. So, this is ductile material. So, for ductile material, we as a designer, I do not want to take my material beyond the elastic limit or the yield point. So, this is SYT is the failure stress for me, because I do not want to get my design into the failure zone even in engineering failure. So, therefore, this failure stress is SYT, and if allowable stress I denote by sigma A, then factor of safety mathematically I can give, or I can decide the allowable stress, the failure stress upon factor of safety, that is allowable stress. Design stress we need to calculate for the design purpose. So, this is factor of safety SYT upon sigma A. So, from this formula we generally find out the allowable stress, or sigma D is the design stress. This is equal to SYT upon factor of safety, right. And if it is in working condition, so working factor of safety you can calculate the failure stress upon working stress, that is a working factor of safety. Sometimes it is asked in any interview or in any question paper, you may be asked what is the design factor of safety, what is the working factor of safety. So, this is you can speak. Then for brittle material, this is a brittle material, there is no yield point. So, there is only it will rise up to here and it get fractured, that is called the ultimate. So, SUT. So, SUT is the ultimate tensile strength, and it is called or it is termed as the failure stress for the brittle material. So, factor of safety we can define this SUT upon sigma A, and यहाँ से भी इसी तरीके से हम सिग्मा ए अगर ब्रिटिल मटेरियल है तो हम सिग्मा ए लेते हैं SUT upon factor of safety. This factor of safety will be considered or will be selected by the designer on the basis of the information available and his wisdom and the experience. Right. Now, we come to, after factor of safety, we come to the theories of failure. So, what is design equation before moving to the theories of failure, and if it is a unidirectional loading condition, suppose this is a member, it is subjected to tensile load F, and this is a cross section area A. So, I can calculate the induced stress sigma, that is equal to F upon A, that is all of you are aware from your strength of material course, force upon area. I am not considering here any other effect which we will consider during our design, real design. So, this is sigma is equals to F upon A, may say I. So, this is the induced stress, and if it is unidirectional, then on UTM, universal testing machine, you have performed the tensile test, you will find this is SYT. Yield point in tension, that is the failure stress, or that is the this is the maximum stress level you can reach up to with the factor of safety 1. If you need some factor of safety, then your limiting value is this, and this is your limiting value. So, if I generate, if I write a relationship between the induced stress and this allowable value or allowable stress, if I write, this is called the design equation. So, this value should be always greater than or equal to the induced value, then this is called the successful condition. And this is very easy when we are considering the unidirectional loading condition, but in practical cases, then the practical and real time problems, the loading is a complex nature, and it is 2 dimensional, it is 3 dimensional, or various tensile and compressive etcetera, then it is very difficult what stress we should consider for comparison to get this design equation. So, then the theories of failure will come into the picture for the complex state of stress. With the help of theories of failure, we derive or establish the design equation for the designing or for determining the dimensions, and under this there are the various theories of failure. So, what is theories of failure? In the case of uniaxial loading, it is very easy to compare the strength with the induced stress and to predict the failure of the material. This is one what I have discussed here, and uh, for next. But in case of biaxial or triaxial stresses, it is very difficult. So, we have to move to some other reason, and here we will consider the principal stresses and the relationship with the strength. So, what type of the stress, what type of the theories of failure? We have the following theories of failure may be used for the design: maximum principal normal stress theory, maximum strain theory, St. Venant's, maximum shear stress theory, that is the Tresca-Guest theory, maximum total strain energy theory, maximum distortion energy theory. So, these are the theories of failure which I will discuss in the next lecture. So, in detail, and we will discuss what theory of failure is applicable for what type of the materials and what type of the loading is to be considered for this particular type of the theory of failure or not. So, we will discuss about the theories of failure in the next lecture. So, for today's lecture, this is from my side. Thank you very much.